Okay, so we discussed about that, means how to find out the x value if greatest near x is given. So if greatest near x equal to n, they will say x will lie between n and n plus 1, where n can be equal also. And not equal to n, then it will be either less than n or it will be greater than equal to n plus 1. These two cases you have to remember. And remember, greatest near cannot be non-integer. It will be always integer. So this point we already discussed. Now let's go ahead and further things. Inequality of quotation here. See, there is no formula because I don't want that you should learn formula or something like that. You try to visualize yourself and develop the formula. For example, no need of writing, just watch it. Suppose I say greatest near x is greater than, only greater than 1. Think carefully. So what is the meaning? Greatest near x greater than 1. So it means they are saying greatest near x may be 2, maybe 3, maybe 4, because greatest near x cannot be 1.2. So it will be 1, 2, 3, 4, so on. That means greatest near x value, if you see on the number line, this is 0, this is the 1, this is the 2, this is the 3, this is the 4, and so on. That means greatest near x should not be 1. This should not be 1. It should be 2 or 3 or 3. Means this is possible, this is possible, this is possible, this is possible, and so on. So where x should be? If I am asking where x should be, is it possible x can be here? No, x cannot be, because if x is here, then greatest near x will become 0. Greatest near x cannot be here, otherwise 1. Here cannot be. Can it be on 2? X can be on 2? Yes. So greatest near x will become 2, and that is the expected. Can it be x can be here? Yes. In that case, greatest near x will become 2 again. That will be acceptable. Here acceptable. Means this will give you x greater than equal to 2. Did you understand this system? So whenever greatest near x greater than 1, so we'll say that key greatest x greater than equal to 2. Same way, if I say greatest near x greater than n, n is integer. N is integer. So what is the possibility? Orally you can think x greater than equal to n plus 1. Did you understand the point? Same way, if I say greatest near x greater than 3 by 2, greater than 3 by 2. Is it possible? Yes, very much possible. Why? It's saying greatest near x greater than 3 by 2. So greater than 3 by 2 means either 2 or 3 or 4. Then also this answer will be. Have you understand? So always use the logical brain to apply this. Don't try to learn as a formula, but we will write few formulas, but we will not use that. We will use by immediately on the spot, because that much you cannot remember. So if we can say, if this is I'm writing just to, you should know what are the cases can be happen. Greatest near x greater than n, then x greater than equal to n plus 1. I hope it's clear to everybody. Condition, n should be integer. If n is not integer, then make this diagram and try to write the answer. If I say greatest near x greater than equal to n, please tell me in that case what will happen? N is integer. What will be answer? If greatest near x greater than equal to n. We can take some example and immediately derive it. No, it's so simple. Got it? We can do like this. We can write n here, n plus 1 here, n plus 2 here, n minus 1 here. Greatest near x greater than equal to n means Is it possible? Yes. The greatest near x value, this possible. This value possible. This value possible. So x should be where? I'm interested in x. So x, is it possible x can come here? Look the pen and tell me, is it possible x can come here? No. Why? Then what will happen? Greatest near x will become n minus 1, which is not possible. So x should be either here or beyond this anywhere. So we'll say what? X greater than equal to n. I hope able to understand all of you. So whenever greatest near x greater than equal to n, then x will be also greater than equal to n. Again, I'm saying it's just making cases so that you should know what are the possible cases can be happen. But when the question will come, use your common sense and then solve the questions. That is always way. Because I also don't remember single formula. I always do by this way. Next, if I say greatest near x less than n, then think what can be happen. Of course, n is integer. N belongs to integer. Got it? Greatest near x less than n means what is the first value of greatest near x can be happen? N minus 1, n minus 2, n minus 3 and so on. Is it possible x can be here? No. Otherwise greatest near x will become what? N. Is it possible x can be on n? No. Otherwise greatest near x will become n. Is it possible x can be here? Yes. Then greatest near x will become what? N minus 1 and that is accepted. So we'll say what? X will be less than n. X will be less than n. Did you understand everybody? Same way, if greatest near x less than equal to n, very simple oral question. X greatest near x less than equal to n means equal to n also can be happen, means this also is possible. Is it possible x can be here? Yes. Can be here? Yes, because greatest near x will be. Can be on n plus 1? No. Otherwise greatest near x will become what? N plus 1. So we'll say x will be less than n plus 1. Of course, n belongs to integer. Did you understand everybody? All of you wrote it. Can I go ahead? If you're still writing, please take a screenshot. I'm going to change the page. Let's do some few questions. Simple. Find x if first bit of the question. Greatest near x minus 1 by 2 less than 3. Second bit, greatest near of mod of x minus 3 greater than 5 by 2. Third bit, greatest near of log 2 mod x less than 2 less than equal to 2. Fourth bit, greatest near of x minus 1 by 3 greater than equal to 1 but less than 5. Fifth bit, greatest near of x minus 5 less than equal to 5. Solve this 5 question quickly, everybody. See, first one, I guess it's a very simple question. Greatest integer of x minus 1 by 2 less than 3. Less than 3 means, this way try to means it can be 2. First value should be 2. So first value 2 means what? X minus 1 by 3. X minus 1 by 3 should be less than 3. Yes or no? The first value should be 3. So from here, x will be element of minus infinity to 10. Directly I am writing the answer. How many of you got it? Okay. Now, second question. Greatest integer of mod x minus 3 greater than 5 by 2. See, greater than 5 by 2. Greatest integer of something is greater than 5 by 2 means 2.5. So 2 and 3 greater than 5 by 2. Greater than 5 by 2. 5 by 2 is here. Greatest integer of t something greater than 5 by 2 means first value of greatest integer x is what? 3. 3, 4, 5 like that. So x should be where? X should not be here. Otherwise, greatest integer x will become 2. So x should start from where? From 3. So this will give you what? First question, something mistake I did. Oh, okay. Printing mistake. That is not a problem. 2. Yeah, 2 is there. Thank you. 2, 3, 6 plus 1, 7. It will be 7. That is all. क्या पढ़ा? भूल गया मैं. हाँ. So it should be, x should not fall here. X should start from this point only. So I will say mod x minus 3 must be greater than equal to 3. From here, mod x greater than equal to 6. Now simply it's a mod inequality, nothing else. Am I right or not? So mod inequality means x will be minus infinity to minus 6 close union 6 to infinity. How many of you got it? Huh? Very few. Okay. Third question. Greatest integer of log mod x base 2 less than equal to 2. चलो ठीक है, इसको करते हैं. We'll do separately. So greatest integer of something less than equal to 2. So if I say greatest integer of t less than equal to t2, that means t will be less than 3. Less than 3. Am I right or not? So I will say log mod x base 2 will be less than 3. Since base greater than 1, so what will happen? This log will go other side. So mod x will be less than 2 power 3 means 8. If you try to remember, whenever log go other side, to left side you have to put one formality from your side greater than 0. Yes or no? Anyhow, this is always greater than 0, but it can be equal to 0. That's why we have to put greater than equal to 0. So now mod x less than 8. Mod x less than 8. How will you solve it? X will belongs minus 8 to plus 8 except 0. Why? Otherwise x will become 0. This will be the answer. How many of you got this answer? Exactly same. Now next one. This is 1 and 5. Now there is no formula. I didn't give you any formula from this. This you have to use your common sense. 1 and 5. ये 1 here. This is the 5. Greatest integer x should be greater than equal to 1. Okay. So x can be 1? Yes. X can before 1? No. From 1 to go tick, 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 no problem, no problem, no problem. Can it be 5? No. It should not be 5. So 5 should be open. That means x minus 1 by 3 should be greater than equal to 1 but less than 5. Check it, I did correct. I may do mistake. So x minus 1 will lie between 15 to 3. So x will be less than 16 to 4. The final answer 4 close to 16. Open. How many of you got the same answer? Good. Now, next one. This greatest integer x minus 5 less than equal to 5. First thing is that they are making you fool. This is already integer. Greatest integer x is integer or not? This is the integer. So greatest integer minus integer will be integer. So there is no sense of this greatest integer. Did you understand? This greatest integer does not have any meaning. So outside greatest integer I can remove very easily. So let's remove it. Question will become little bit simple, nothing else. So I will get greatest near x minus 5 less than equal to 5. So greatest near x less than equal to 10. So x less than 11. So final answer minus infinity to 11 if I did correct. How many of you got it? Okay. So this way the greatest near inequality will come. Now give the heading graph of y equal to greatest near x. Graph of y equal to greatest near x. How we will draw the graph of y equal to greatest near x? Making cases, because we can easily make the cases and do. Look, at x equal to 0, greatest near x will be what? 0. At 0.1 again 0, at 0.2 again 0, till when 0? Till 1 0, but at 1 it's not 0. Okay. This is the one. At 1 where is graph? At 1. After 1 where is the graph? As you go away from 1, graph will be still 1 1 1 1 1 1 1 1 and till 2 it will be 1, but at 2 it's not 1. At 2 graph will become this way, 2 only. After 2 again it will be 1 1 1 1 1 1 1 and till 3 it will be 1. 2. I'm sorry. This is 3. This value is 1, this value is 2. Have you understand? Now all of you understood the pattern. We have to just draw one line like this. Left side close, right side open. So no need of thinking further. Simply we can draw. Here, this is again further. This is this side also. If you come, so left side close, right side open. This is this point minus 1. This is this point minus 1, minus 2, and so on. If you look, it look like steps, looking like steps. That's why sometimes some people call it step function. Be clear, this is not official name. Generally in Andhra Pradesh, Telangana side, the people, that side, some people I seen that they don't know greatest integer word. They use only step function. So, if anyway, but it's not official name. Because it's look like a step, people call it a step function. Is this clear? Chaliye, let's go ahead. Few properties you can write. Properties of greatest integer x. Simple, small property which you already know. Maximum you know. Greatest integer x equal to x if x belongs to integer. One more time, a greatest integer x can be x. What is that? Greatest integer x can be x when x is integer, and one more time it can be x when x approaches to infinity. When x approaches to infinity, always keep in mind. Next one. Greatest integer of minus x is equal to minus 1 minus greatest integer x. Minus 1 minus greatest integer x. Wait, some problem. What problem? If I ask you what is the greatest integer of minus 3, so what will you say? Minus 3. But if you use this logic, the greatest integer of minus 3 should come as what? Minus 1 minus greatest integer of 3. Greatest integer of 3 will be what? 3. So this will become total what? Minus 4. So always remember this is valid if x does not belongs to integer. Are you getting my point? If x belongs to integer, तो greatest integer x minus x will become minus x itself. There is no problem. Are you able to understand, everybody? How I wrote this statement? This statement, how I am writing? Greatest integer minus x equal to minus 1 minus greatest integer x, how I am writing? Listen me carefully. Suppose I say, this is your 0, this is minus 1, this is 1, this is 2, this is 2. Imagine, here is the x. I don't know x is between what integer. Here is minus x, sorry. So minus x reflection will be somewhere here or not? Right? Minus 1 reflection 1, minus 2 reflection 2. So minus x reflection will be x somewhere right side or not? So suppose x lie between n and n plus 1. So minus x will lie where? That will lie between minus n minus 1 to minus n. Have you understand? Just mirror image I am making. If you take a mirror image with respect to origin, so this image will come first and this image will come last. In the real number line, left side of 0 is the mirror image of the right side of 0. Okay. Now think carefully. Greatest integer minus x will be what? Look this, left side integer. So what do you say? Minus n minus 1. Are you able to visualize what I am trying to tell you? From here, greatest integer x will be what? N. Left side integer. So this n I can replace here. So what you will get? Minus 1 minus greatest integer x. And that's what I am writing. Something gone in the mind or not? So this is why greatest integer minus x equal to minus 1 minus greatest integer x if x not integer. If x integer, so greatest integer minus x will be minus x only, because whenever x integer, so there is no sense of the putting greatest integer x. Using this logic, if anybody asks you, what is the value? This is a very common expression, that's why I am writing as a property. Greatest integer x plus greatest integer minus x. So we can use logic from here. This I will go this side. So greatest integer x plus greatest integer minus x will be minus 1 if x not integer. From here I just got it. Are you getting? If x integer, so greatest integer x will become x and greatest integer minus x will become minus x. The total value will become what? 0. Very common property. So many times we will use this property. Next, greatest integer x plus greatest integer y will be x plus y if x and y belongs to integer. I don't have to explain this point, all of you understood. By x and y both are integer, so greatest integer x plus greatest integer y will be written as x plus y. Now think carefully. This will be greatest integer, something wrong I wrote. I'm sorry. Greatest integer x plus y, whole greatest integer. So if x and y are integer, so x plus y will be also integer. So greatest integer x plus y will become x plus y. If x and y are not integer, then it will be written this way only if fractional part of x plus fractional part of y lie between 0 and 1. Nothing able to understand. X and y are not integer. If it's not integer, so x will have fractional part of it. Y will also have the fractional part of it. So fractional part of x plus fractional part of y, if their summation is between 0 and 1, then we can write this way. Better way you will understand when we will see the property of fractional part of it. Right now you have to just write. Otherwise this value is plus 1. If fractional part of x plus fractional part of y will lie between 1 and 2, because fractional part of x will lie between 0 and 1 and fractional part of y also lie between 0 and 1, their summation may cross 1. So if its may crosses 1, so this value will be there. For time being, write down that as a property. Derivation you will see in the after fractional part of x. Is this clear to everybody? So these are the few property which I will suggest you should practice 2-3 times and you should keep in mind. It will help you. If you don't remember, then also on the spot you can derive and do the question. I'm not saying you cannot do, but if you remember, sometimes question will become quickly. It will be very easy. So there's a lot of properties are there. So all those properties are useless. The property which is really going to be used in future, that's why I'm giving you 4 property only. That's all, nothing else. One more is there, which we should write it. 5 number will look good. Greatest near x plus m is equal to greatest near x plus m if m belongs to integer. Again, very important property. This property I want to talk with you. Again, proof you will understand only once the fractional part of x is done. What is this property meaning? If I say, what is the greatest near of x plus 5 somewhere is coming. Suppose somebody says, solve this equation or solve this inequality. Okay. So it will look very difficult, how to do this. But 5 is integer. If 5 is integer, to this question I can write greatest near x plus 5 plus greatest near x greater than or equal to. Now nothing left in the question. That's why this property is very important. Never try to think x plus 1 by 2 is there. You cannot write greatest near x plus 1 by 2. This is wrong. Have you understand? You can write greatest near x plus y only if this is the what is the part. How this property from here you can understand. Suppose x plus f, x plus 5. Think carefully. What is the fractional part of this? 0. 5 fractional part of 5 is what? 0. Because this does not have the decimal part. X will have fractional part of something. So fractional part of x plus fractional part of 5 is lying between 0 and 1 or not. This does not have fractional part. This is having only. So their summation. So this category will apply. To greatest near x plus 5, we can write greatest near x plus greatest near 5. And greatest near 5 will be 5. That's why this is. Have you understand the point? Some people gone in deep sleep. Is it clear to everybody? Changing the page. If anybody have to still writing, please take a screenshot. Now, fractional part of x. As you know that greatest x always written as what? Greatest near x plus fractional part of x. So from here we can say fractional part of x equal to x minus greatest near x. We can write like this or not? Actually, I don't want to teach you again throughout complete fractional part of x. Use this logic and calculate the value. Because we are more comfortable with the greatest near x. So whenever they are asking you fractional part of something, use this logic. Unnecessary, don't try to learn separate property, separate method. It's a waste of time. I also do like that only. Suppose somebody say, what is the fractional part of 2.9? So I will say this will be 2.9 minus greatest near of 2.9. And greatest near of 2.9 is very simple. Yes or no? That will be 2. So answer will be 0.9. Suppose I say greatest near of minus 5.1. So that will be minus 5.1 minus greatest near of minus 5.1. Right now I am writing, but orally you can do. So minus 5.1 and this greatest near will be what? Minus 6. Minus greatest near of minus 5.1 minus 6 minus plus 6. So it will be 0.9. Did you understand? If anybody asks greatest near of 5 will be what? So you will say fractional part of 5. So you will say 5 minus greatest near of 5 and that will be 0. So we can simply say if fractional part of any integer is always 0. Fractional part of any integer will be always 0. Obvious, integer does not have decimal part. So that's why fractional part of this will be always taken as a 0. Is this clear to everybody? Fractional part of x always lie between 0 and 1. This point you should never forget. It's the most important thing. Fractional part of anything always lie between 0 and 1. Suppose somebody say, what is fractional part of infinity? That also I cannot say, but it will be a finite number and that will lie between 0 and 1. That will lie between 0 and 1. Don't try to use your hi-fi brain. Sir, I will use this logic and this I will say infinity minus greatest near of infinity, and just now you told greatest near infinity is the infinity, so infinity minus infinity and value is 0. Infinity minus infinity is not 0. Understood? So please, mathematical operation does not work on the fraction when infinity get involved. Only thing, hypothetical things, all these infinity nobody can reach. So it's just greatest near fractional part of any number, either a small number or very big number, the whole value will always lie between 0 and 1. Chaliye. Now, graph of, give the heading, graph of y equal to fractional part of x. Graph of y equal to fractional part of x. How to draw graph? We'll use same logic and try to do. Think carefully. When x is between 0 and 1. When x is between 0 and 1. Watch carefully. Actually, we are trying to draw the graph of fractional part of x. So that I can say x minus greatest near x. So when x is 0, y will be 0. Why 0? X 0, 0 is integer. When x is 0.1, this value will be 0, so y equal to x. When x 0.2, x, because this value will be always 0. So till when it's 0? Till 1. So till 1, which graph you will draw? Y equal to x. At 1, not y equal to x. This point everybody understood? Till 1. At 1, again the value will become 0. At 1, again the value will become 0. Why? Because 1 minus 1, 0. After 1, what will happen? If it's x is 1.1, x is 1.1, so this value will become 1. This will be x only. So x minus 1 means we have to draw x minus 1 graph. Think carefully. Basically, this is the graph of y equal to x. Now I want y equal to x minus 1. The same graph I will shift 1 unit towards right. Same graph I will shift 1 unit towards right. This graph I will shift from here to 1 unit towards right. Graph method, because x minus 1, 1 unit right. Same way, add 2, what will happen? Add 2 here, again 0. And after 2, this is the y equal to x minus 1 now. The y equal to x minus 2 will come. Y equal to x minus 2 will come. Yeah, ऐसे. All of you able to understand? This is the which graph? Y equal to x minus 2. And so on. I hope you understood now. Same things will continue. Same thing will continue. This side also. This value is minus 1. And so on. This coordinate is 0, 1. This graph is also saying that key fractional part of x always lie between 0 and 1. Is this clear to everybody? This, people say that it look like flower, and that's why this function sometimes people call it as a flower function. I don't know why. I never able to see flower inside this. Nowhere flower looking. But people sometimes they used to call it as a flower function. Chaliye. Sometimes questions can come, equation. Can I change the page now? If anybody is still writing, take a screenshot. Be clear, this only 4 strip is not there, infinite strip, it will continue. I just draw only 4. Sometimes they ask equation based on the greatest near x, fractional part of x, everything involved. I will just show you 1-2 question. Write a question. Find x if x plus greatest near x is equal to 3 fractional part of x. I will solve it. Watch it. X plus greatest near x equal to 3 fractional part of x. If you try to think, variable is x only, but there are the 3 different type of function involved inside this. One is the plain x, another greatest near of x, and fractional part of x. Whenever such kind of question is coming where the linear expression of x, greatest near x, fractional part of x is coming, always try to get the value of fractional part of x in term of greatest near x. So what we can say? We know that x is always equal to what? Greatest near. Anytime I can write like this or not. So this equation I can say greatest near x plus fractional part of x, in place of x I wrote it, plus greatest near x equal to 3 fractional part of x. So from here 1 fractional part of x will go this side, so we'll get 2 greatest near x equal to 2 fractional part of x. 2 bye bye. So I got fractional part of x equal to greatest near x. Yes or no? Why I always try to get fractional part of x, you'll understand. We know that fractional part of x always lie between where? 0 and 1. Greatest near x can be anything, but fractional part of x having limitation. That's why everything I will try to convert in terms of fractional part of x. So fractional part of x equal to greatest near, I put it here. So we got what? Greatest near x lie between 0 and 1. If greatest near x lie between 0 and 1, what is the greatest near x value? Greatest near x cannot be 0.5, cannot be 0.2. So from this, what is the greatest near x? Only one value will come. What is that? 0. Yes or no? 1 is not equal, no? Greatest near x minus 0, we got it. This value in the equation 1 I can substitute. In equation 1 I can substitute, so I will get fractional part of x. So fractional part of x is also 0. If you put it here, the fraction part of x is also 0. So x will be what? X is nothing but this plus this, so 0. So only one solution of this equation, that is the x equal to 0. Did you understand? Is it clear? Write it quickly. Done. One question, all of you. I am expecting answer. This is JEE 93 4 marks question. What was that? Find x if 4 fractional part of x equal to x plus greatest integer of x. Once you get the answer, let me know. Done. This much time. This much time. Chalo, I will do 4 fractional part of x equal to x. I can write what? Greatest integer x plus fractional part of x plus greatest integer x. So this fractional part of x I will one side. So I will get 3 fractional part of x equal to 2 greatest integer x. My purpose is that to get the value in term of greatest integer. First equation. What is the other condition? Fractional part of x always lie between 0 and 1. So 2 greatest integer x by 3 will lie between 0 and 1. So greatest integer x will lie between 0 and 3 by 2. So greatest integer x will be what? Either 0 or 1. Because 3 by 2 is the 1.5. The only integer can be happen. This value I can substitute here. So fractional part of x will be either 0, when a 0, 0, and when 1, 2 by 3. So x will be what? This plus this. 0 and 5 by 3 is the answer. Finished. This is the answer. Did you understand? It's so simple question, not able to solve. So by this your greatest integer is over. One question I am giving you for homework and try. It's a good question. Find x if x cube minus greatest integer x equal to 3. Try it and send me solution if you can solve it. Here this logic will not work. Well, here if you will put x equal to greatest integer x plus fractional part of x, you will collapse. Greatest integer x plus fractional part of x whole cube will come, square, cube, and no chance of solving. You have to use the logic of graph. Think and try to solve this question. We'll continue. In the next class, we are starting the function chapter. Okay, we'll discuss this question and function chapter will be getting started. Thank you. We'll see you in the next class.